engines used by the British company Land Rover in its 4A, 4 vehicles have included 4-cylinder petrol engines, and 4-cylinder and 5-cylinder diesel engines. 6-cylinder engines have been used for Land Rover vehicles built under license. Land Rover have also used various 4-cylinder, V8 engines and V6 engines developed by other companies, but this article deals only with engines developed specifically for Land Rover vehicles. Initially the engines used were modified versions of standard Rover car petrol engines, but the need for dedicated in-house units was quickly realized. The first engine in the series was the 2-liter diesel of 1957, and this design was improved, expanded and modified over several versions, culminating in the 300 TDI of 1994, which ceased production in 2006. Over 1.2 million engines in the series have been built. From 1998 the Td5 engine was fitted to Land Rover products. Whilst this 5-cylinder turbo diesel was unrelated in any way to the 4-cylinder designs and was originally intended for use in both Rover cars and Land Rover 4A/4s, it only reached production in its Land Rover form. It was produced between 1998 and 2007, and 310,000 Td5s were built. Production of these engines originally took place at Rover's satellite factory at Cox Green in Birmingham, whilst vehicle assembly took place at the main Rover works at Solihull. After Land Rover was created as a distinct division with British Leyland in 1979, production of Rover cars at Solihull ceased in 1982. A new engine assembly line was built in the space vacated by the car lines, and engine production started at Solihull in 1983. The engine line at Solihull closed in 2007 when Land Rover began using Ford and Jaguar engines built at Dagenham and Bridgend. Some Land Rover engines have also been used in cars, vans and boats. This article only covers engines developed and produced specifically for Land Rover vehicles. It does not cover engines developed outside the company but used in its products, such as the Rover V8. The Rover IOE petrol engines or the current range of Ford Jaguar-derived engines. The engines are listed below in the chronological order of their introduction. Description and specifications. 2-liter diesel . Throughout the 1950s there was an increasing demand for a diesel-engined Land Rover. Diesel technology had improved, making small-capacity high-speed engines practical. Diesel power had also become prominent in industrial and agricultural uses throughout the world, and fleet users of Land Rovers were often in the situation where their Land Rovers were the only petrol engine vehicles in their fleet, making spares, servicing and fuel supply more complex. The Rover Motor Company was in talks with Standard Triumph in 1954, with the possibility of a merger. Standard were Britain's pioneers of road-going small diesel engines, with the 20C engine fitted to Ferguson tractors in the Standard Vanguard car. Rover engineers were able to study Standard's diesel designs as part of these. The merger was called off, but Rover had gained vital experience and knowledge in developing small diesel engines. The result was a wet-liner 4-cylinder engine. Fuel injection equipment was from CAV, and the engine used Ricardo's Comet swirl chambers, but with Rover developed impulse to produce quieter and smoother running. Heater plugs were fitted to each combustion chamber to improve starting. The engine was launched in the Land Rover in 1957. The vehicle had to have an extra 2 inches let into the chassis in the engine bay to enable the new engine to fit. The engine's power output and speed range was close enough to the existing petrol engine to allow the same transmission unit to be used on all vehicles. Layout: 4-cylinder, inline block head, cast iron valves, OHV, chain drive camshaft, pushrod operated capacity, 2052 cc bore, stroke, 85.7 mm, 88.9 m compression ratio, 22.51 fuel injection, CAV DPA rotary pump and CAV Pintor injectors power, 51 horsepower at 3,500 rpm torque, 87 lb-FAFT at 2,000 rpm production, 1957 Euro 1962 used in, Land Rover Series I and Series II. 2.25-litre petrol . The Series II Land Rover launched in 1958 was larger, heavier and more complex than the original, and there was an ever-present need for higher-powered engines. Also, the Rover petrol engines in use at the time, with the archaic inlet over-exhaust valve layout and were approaching the age of 20 years in design terms. A new, larger petrol engine specifically developed for the Land Rover was needed. The existing 2-liter diesel engine was used as a basis, but with a radically changed internal structure. The new engine was a Euro dry-liner type, and a wider bore was used to improve low-speed torque output. Despite the numerous changes, the petrol engine could use the same machining line as the diesel, establishing a design commonly used between Land Rover's petrol and diesel engines that would survive for decades. The 2.25-liter petrol was the most popular engine option right up to the mid-1980s and established a worldwide reputation for reliability and longevity. The engine's relatively low compression ratio and general strong design made it tolerant of poor quality fuel and oil as well as infrequent servicing. With proper maintenance, these engines can easily survive more than 250,000 miles of service. This was partly due to the commonality between petrol and diesel versions, making the petrol versions somewhat over-engineered for the job. They retained the extraordinary strength characteristics of the diesel while being much less stressed. The only major change to the design was the fitting of a 5-bearing crankshaft in 1980, which improved bottom-end strength and refinement. Despite its utilitarian origins, the 2.25-liter petrol is a quiet, smooth-running engine, and this enabled Rover to fit it to their P4 saloon car as the Rover 80. Various power outputs were available for this engine depending on the compression ratio and the amount of emissions regulation equipment fitted. Layout: 4-cylinder, inline block head, cast iron valves, OHV, chain drive camshaft, push rod operated capacity, 2,286 cc bore, stroke, 90.47 mm, 88.9 m compression ratio, 71/81 carburetor, Solex, Zenith, Weber power, 74 horsepower at 4,200 rpm torque, 120 lb-FAFT at 2,000 rpm production, 1958 to Euro 1985 used in Land Rover Series 2, Series 3, and 9110/127. Also Rover P480 equals 2.25-liter diesel equals, the Series 2 Land Rover was a sales success, but there was still room for improvements. In 1962 the slightly altered Series IA was launched. As well as some suspension and steering system changes, the biggest update was an improved diesel engine. This shared many parts with its petrol-fueled sibling, including the block, valve gear, cooling systems and lubrication systems. A forged crankshaft was used for added strength, and different pistons were needed. The cylinder head used the same basic casting, but was very different internally, being in essence an updated version of that used on the original 2-liter engine, to which the new diesel bore a strong external resemblance. Like the 2.25-liter petrol, the 2.25-liter diesel was a dry-liner design. It was built on the same production line as the petrol engine, and the flexibility of the basic design was much in evidence. For example, where the diesel engines had their fuel injector pumps, the petrol engine had its distributor fitted. Although it offered a modest improvement in power and a useful jump in torque, the main benefit of the new diesel engine was that it was much quieter and more efficient than the older unit. It also proved to be much more reliable in service. Like the petrol engine, the diesel was upgraded to a 5-bearing crankshaft in 1980. The engine was fitted to the Austin FX4 black cab between 1982 and 1985. FX4s fitted with the engine were designated FX4R. In this application the engine gained a reputation for very short service life and unreliability. This was caused by the significantly greater time spent at idle speed in the black cab than in the Land Rover. Solihull engineers had warned car bodies, builders of the FX4R, that this would cause problems as at idle speed the engine's oil pressure dropped, causing the automatic tensioner unit for the timing chain to not operate fully. At the high number of hours spent at idle speed this caused the timing chains to stretch, causing incorrect fuel injection timing which greatly reduced engine life. The 10J engine was also adapted into a marine engine by Mercury of the USA and sold under the Mercruiser 165 name. Layout: 4-cylinder, inline block head, cast iron valves, OHV, chain drive camshaft, pushrod operated capacity, 2,286 cc borer, stroke, 90.47 mm, 88.9 compression ratio, 23:1 fuel injection, CAV-DPA rotary pump and CAV plantar injectors power, 62 horsepower at 4,000 rpm torque, 103 lb-FAFT at 1,800 rpm production, 1962 Euro 1984 used in Land Rover Series 2, Series 3, and 110. Also carbured is FX4 and sold as a Mercury Marine engine. There is also evidence of the 10J engine being offered as a conversion for Volga saloon cars by a Belgium-based company. 2.5-litre diesel engine Land Rover's radically updated product line was launched in 1983. Initially only the long-wheelbase 110 was available and it was sold with the same engine lineup as the preceding Series 3 model 2.25-litre petrol and diesel engines and the 3.5-litre Rover V8. However, Land Rover planned a series of rolling improvements. Launched shortly before the short wheelbase 90 model in 1984 was a 2.5-litre diesel engine. This was little more than an updated version of the existing diesel unit. The stroke was lengthened to improve torque, and an updated cylinder head was used to reduce noise and emissions. A more modern injector pump improved fuel economy and an improved glow plug system improved cold starting performance. The most significant change was the swapping of the chain-driven camshaft for one driven by a fiber-toothed belt, which also drove the repositioned injector pump. The drive vacated by the injector pump was used to power a vacuum pump for the brake servo system. To reduce engine weight, extensive use of aluminium castings was made for the cam-bolt case, vacuum pump, rocker cover and other parts. Other small improvements were made such as the fitment of a spin-on cartridge oil filter instead of older, harder-to-change element type and the fitting of under-piston oil jets. In the mid-1980s Land Rover was part of the Land Rover Group, responsible for production of the Freight Rover van. The 2.5-litre diesel was fitted to the Freight Rover 300 series in the FX4 taxi. The engine became a special order-only option after the introduction of turbo diesel engines but remained in production until 1994. The British Army used this engine in the vast majority of the 20,000 Land Rovers it bought between 1985 and 1994. A manufacturing flaw with pistons combined with Army maintenance practices caused the engines to overbreathe and ingest their oil, leading to piston failure. Late military spec engines had a centrifugal separator in the breather system, allowing excess oil to drain back to the sump. These engines were designated 13J and 11J. These later, modified engines were the first in their class to pass the Ministry of Defence's arduous 500-hour durability trial. Layout: 4-cylinder, inline block head, cast iron valves, OHV, belt-driven camshaft, pushrod operated capacity, 2,495 cc borer, stroke, 90.47 mm, 97 compression ratio, 21:1 fuel injection, Lucas CAV-DPS rotary pump and CAV plantar injectors power, 68 horsepower at 4,200 rpm torque, 114 lb-FAFT at 1,800 rpm production, 1984 Euro 1994 used in Land Rover 9110/127, and Defender. Also Freight Rover 300 and carbured is FX4. 2.5-litre petrol engine At the launch of the 90 Land Rover had insisted that there would not be a 2.5-litre development of the petrol engine. However, buyer demand and economics made the change inevitable. The larger petrol engine was launched in 1985 and, like its 2.25-litre predecessor, it had much in common with the diesel engine. The block was identical, as were most ancillary parts. The key difference was that the petrol engine retained its timing chain, since it lacked the need to drive an injector pump. The cylinder head was adapted to use unleaded fuel. As before, the engine was smooth and refined, and provided the Land Rover with adequate road performance. However, as fuel prices rose and diesel engines improved, sales of the petrol engines fell, especially in Europe. It remained a popular option in Africa and other areas where fuel prices or the simplicity of the engine made it an attractive option. It remained available until 1994. Although by this time sales had dwindled to almost nothing in the face of a new generation of refined diesel engines. By this time buyers were limited to those with specific reasons to buy petrol engine vehicles. For example, several police forces in the UK bought fleets of 2.5 petrol Defenders in the mid-1990s because the diesel engine vehicles would have caused maintenance and logistical problems when operated alongside the fleet of standard patrol cars, all of which were petrol-fueled. Layout: 4-cylinder, inline block head, cast iron valves, OHV, chain drive camshaft, pushrod operated capacity, 2,495 cc bore, stroke, 90.47 mm, 97 mm compression ratio, 8:1 carburetor, Weber power 83 horsepower at 4,200 rpm torque, 133 lb-FAFT at 2,000 rpm production, 1985 Euro 1994 used in, Land Rover 9110/127 and Defender. Diesel turbo equals. Land Rover's global sales collapsed during the early 1980s. This was mainly due to foreign competition offering larger, more powerful, more comfortable vehicles. Land Rover suffered from poor build quality and materials during the 1970s, and by 1983 the then current Series 3 model was distinctly outdated, despite recent improvements. Land Rover decided to focus the sales of its 9110/127 range on the UK and Europe, for which it required a diesel engine with significantly better performance than the 68 horsepower 2.5-litre type then in production. Project Falcon was started in 1984 to develop a turbocharged version of this engine. The resulting engine was Land Rover's first production turbo diesel and their first engine to be given a marketing name, the Diesel Turbo, a name given to differentiate it from the VM motor rebuilt turbo diesel then being used in the Range Rover, which was sold as the Turbo D. The Diesel Turbo, although essentially the same as the 2.5-litre diesel, had numerous additions and modifications to allow it to cope with the stresses of turbocharging. New pistons with Teflon-coated crowns and mnemonic steel exhaust valves were used to withstand higher combustion temperatures. The crankshaft was cross-drilled for improved strength and cooling. The block was modified to allow an oil feed drain system to the turbocharger, and the cooling system was improved with an 8-bladed viscous fan and integral oil cooler. The engine was fitted with a high-capacity breather system to cope with the greater volumes of gas flow through the engine. Despite the inherent age of the design, it performed well in tests against its rivals and provided the vital blend of performance and economy the Land Rover had needed for many years. It was the first diesel model to match the petrol engine's 4-ton towing limit and the first to be able to exceed the UK national speed limit of 70 miles per hour. However, early engines suffered several failures. Most serious were failed main and big end bearings and splits or cracks in the block. In 1988 a new block and an improved design of bearing and bearing cap was fitted which solved these issues. The engine's higher internal temperatures meant that the cooling system also had to be maintained to a much higher standard than the earlier engines. Further changes were made in 1989. This time to the breather system to prevent oil being drawn into the air filter. Despite these issues, the diesel turbo was a strong seller. It was the standard engine for the UK and European markets, and Land Rover's sales increased after its introduction. Time has shown that these engines can turn in long service lives if maintained as requerido Euro. Like many early turbo diesels, a lack of maintenance causes failure. Layout: 4-cylinder, inline block head, cast iron valves, OHV, belt-driven camshaft, pushrod operated capacity, 2,495 cc bore, stroke, 90.47 mm, 97 mm compression ratio, 21:1 fuel injection, Lucas CAV DPS rotary pump and CAV Plantor injectors induction, Garrett T2 turbocharger power, 85 horsepower at 4,250 rpm torque, 150 lb-FAFT at 1,800 rpm production, 1986 Euro 1989 used in, Land Rover 9110/127 in Land Rover Llama. Prototype equals 200 TDI equals. In 1989 Land Rover had launched a Discovery, its Range Rover-based family 4A, 4 that quickly became Europe's top-selling 4A, 4. One of the key reasons for its success was its groundbreaking turbo-diesel engine. The 200 TDI was one of the first mass-produced small-capacity direct-injection diesels, with the attendant improvements in power and efficiency that system brings. Developed under the codename Gemini, the 200 TDI was planned from the start to be used on all Land Rover's products. For production reasons, it had to be machined on the existing machinery, so used the same block and crankshaft as the existing 2.5-litre diesel engines. It also used many ancillary parts used on the older engines. However, it was a true break with the past. An aluminium alloy cylinder head reduced weight and noise. A new Bosch injection system gave improved running characteristics and better starting performance. An intercooler boosted power and efficiency further. Lessons learned from the diesel turbo were included, such as the fitment of an inertial separator and the breather system to remove oil before crankcase gases were returned to the air intake. Initially turbocharged and naturally aspirated diesel versions and a carburetor-fed petrol version were to be produced. The direct injection system meant that only machining of the injector sockets was needed to allow the fitment of spark plugs. However, the performance and economy of the turbo-diesel version was such that the other variants were not produced. The 200 TDI was launched in the Discovery in 1989. It was then fitted to the utility Land Rover in late 1990. For this application the engine was slightly detuned and, whilst in the Discovery the 200 TDI used all new components, packaging restraints in the Defender meant that the 200 TDI in this role shared many exterior parts with the diesel turbo. Most obviously the turbocharger was retained in the diesel turbo's high mounting position on top of the manifolds in the Defender, rather than being tucked under the manifolds in the original Discovery version. In 1992 the engine was fitted to the Range Rover. Although the older petrol and naturally aspirated diesel units were theoretically still available, the 200 TDI had better performance and economy than any of them, and so dominated the sales figures. It is still highly regarded by Land Rover enthusiasts and has established itself as a powerful and long-lived unit that with proper maintenance can exceed 300,000 miles of use. The engine's commonality with the older models makes it a popular choice for installation in older Land Rovers. This is done both in original form or with the turbo removed in order to keep the power-torque output within the limits of a series Land Rover's gearbox and for greater ease of conversion. The turbocharged version may also be installed with or without the intercooler. Layout: 4-cylinder, inline block head, cast-iron aluminium alloy valves, OHV, belt-driven camshaft, pushrod-operated capacity, 2,495 cc bore, stroke, 90.47 mm, 97 mm compression ratio, 19:1 fuel injection, Bosch VE rotary pump plus Bosch 2-stage injectors induction, Garrett T2 turbocharger power, 111 horsepower at 4,250 rpms, 107 horsepower at 3,900 rpm torque, 195 lb-FAFT at 1,800 rpms, 188 lb-FAFT at 1,800 rpm production. 1989 Euro 1994 used in, Land Rover Defender, Discovery and Range Rover. Equals 300 TDI equals. Although the 200 TDI engine had been an undoubted technological and sales success, it had certain limitations and flaws that needed to be rectified. Despite their numerous differences, it was still in essence a direct injection version of the older diesel turbo engine. It was also considered rather raucous and unrefined, especially for use in the Discovery and Range Rover models. A special version of the engine had to be produced to fit the Defender, and problems with weak head gasket had been identified. The British Army had not opted for the 200 TDI because it could not be fitted with a 24-volt generator for powering radio equipment. Instead, the Army continued to buy vehicles with 2.5-litre naturally aspirated diesels. Upcoming European diesel emissions regulations meant that Land Rover would be forced to radically alter the engine anyway. The resulting development project produced the 300 TDI engine. Although externally very similar to the Discovery Range Rover version of its predecessor, 208 changes were made. These included modifications to the block, cylinder head, fuel injector system and ancillary systems. The crankshaft, pistons and connecting rods were significantly altered over the 200 TDI. The most obvious external changes were the fitting of a rubber acoustic cover over the engine to reduce noise and the change to a single serpentine belt to drive the ancillaries instead of the multiple V-belts of the older engines. Emissions regulation included the fitting of an exhaust gas recirculation system. Power and torque outputs remained the same, and the engine had been specifically designed to be compatible with all the models in the Land Rover range without any changes. This meant that the Defender engines were fitted in the same tune as the Discovery Range Rover engines. The 300 TDI was noticeably smoother and quieter than the 200 TDI, but was generally found to not be quite as economical in real-world use. It turned out that the Euro I emissions regulations were not as severe as Land Rover anticipated, and so the 300 TDI was able to remain in production until the introduction of the Euro 3 rules. When fitted to vehicles with an automatic transmission, power was increased to 122 horsepower to make up for the power losses in the transmission. These engines had Bosch electronic diesel control systems, where the mechanical injector system was controlled by a drive-by-wire electronic throttle to reduce emissions. The 300 TDI was replaced in 1998 by the 5-cylinder Td5. Bringing to an end the line of Land Rover 4-cylinder engines that can be traced back to 1957. The Td5 engine was loosely based on the Rover Group's L Series diesel engine. The 300 TDI remained in production in Brazil, and was offered as an option on rest of world models. Following Ford's acquisition of Land Rover in 2000, the engine was used in Brazilian-built Ford pickup trucks as well. Increasing emissions laws worldwide and falling sales led to production of the 300 TDI ending in 2006. A much modified 2.8-litre version was built by International Engines in Brazil until 2010, and was available as an aftermarket fitment to Land Rovers through specialist converters. International then became MWM International Motors, and a further update of the 300 TDI design was launched as the 3.0 Power Stroke. Although based around the same block and basic architecture as the 300 TDI, the Power Stroke has major differences such as electronic common rail injection and new cross-flow cylinder head with overhead camshaft. Layout: 4-cylinder, inline block head, cast-iron aluminium alloy valves, OHV, belt-driven camshaft, pushrod operated capacity, 2,495 cc borer, stroke, 90.47 mm, 97 mm compression ratio, 19:1 fuel injection, Bosch VE rotary pump and Bosch 2-stage injectors induction, Allied Signal T25 turbocharger power, 111 horsepower at 4,250 rpms, 122 horsepower at 4,250 rpm torque, 195 lb-FAFT at 1,800 rpms, 210 lb-FAFT at 1,800 rpm production, 1994 Euro 2006 used in Land Rover Defender, Discovery, and Range Rover. Also various Brazil-assembled Ford pickup trucks. Td5 By the mid-1990s the Rover Group was looking to rationalize its engine ranges and produce new designs that would be able to meet emissions legislation for the foreseeable future. The recently released K-Series petrol engine range would be extended to cover that sector, but Rover had no in-house diesel engines suitable for both its cars and its 4A4s. The 300 TDI could not be fitted to any of the car range and was about to fall foul of the upcoming Euro 3 emissions standards. The existing L Series 2-litre diesel was not suitable for use in Land Rover products and could not be developed into such a unit. It was decided to design a new diesel engine family that could be produced in various capacities and states of tune suitable for all of Rover's needs. The development was codenamed Project Storm and design responsibility was given to Land Rover, who were to build the engines. The result was a range of engines using the L series as a chassis. The bore stroke dimensions were the same and the Storm engine used the same piston and connecting rod assemblies. The Storm utilized electronic unit injection by Lucas and a cross-flow aluminium alloy cylinder head on a cast iron block. The designers had aimed at increasing servicing intervals, so the engine incorporated both conventional and centrifugal oil filters. The electronic systems included an anti-stall system to allow heavy loads to be started from rest at idle speed and two programmed operating modes for road and off-road use. The overhead camshaft was chain-driven. The Storm design encompassed 4, 5 and 6-cylinder engines. In the event the takeover of the Rover Group by BMW, who brought their own range of diesel engines, made the Storm engine largely redundant. Only the 5-cylinder version made it to production as the power plant for the Defender and the new Discovery Series 2 as the Td5 in 1998. Offering more power and greater refinement than the 300 TDI, the Td5 greatly improved the appeal of the Discovery but caused concern amongst many operators of the Defender due to its electronic engine management systems, which were considered to be less reliable and more difficult to repair in the field than the mechanical injection systems used on previous Land Rover diesel engines. In deference to these concerns, Land Rover kept the 300 TDI in production for fitment to special order vehicles. It transpired that the Td5's electronics were highly reliable. Early engines suffered two isolated mechanical failures: sudden and complete failure of the oil pump drive and cylinder head shuffle caused by weak retaining studs. Both these faults were fixed within 2 years of the engine starting production, and the Td5 is now considered highly reliable. In 2002 the engine was improved to reach Euro 3 anti-pollution stage, and an EGR valve system was introduced. Electronics were also updated to improve the low-speed throttle response, which had been prone to producing a jerky power delivery in off-road or towing situations. The engine has proved itself on numerous expeditions in hostile terrain. The engine's mechanical strength and electronic control systems makes the Td5 much more tunable than the older engines. Numerous aftermarket companies produce tuning upgrades offering as much as 220 horsepower. The Td5 was replaced in the Discovery by the AJDV6 unit in 2004 and the Ford ZSD424 in the Defender in 2007. Production of the Td5 at Solihull ceased that year, making it the last Land Rover designed and built engine. Layout: 5-cylinder, inline block head, cast iron aluminium alloy valves, OHC, chain-driven camshaft. Capacity: 2,493 cc bore, stroke, 94 mm a, 71.1 compression ratio, 19.51 fuel injection, Lucas electronic unit injection induction, Allied Signal GT20 turbocharger power, 122 horsepower at 4,850 rpms, 136 horsepower at 5,000 rpm torque, 221 lb-FAFT at 1,950 rpm. Production, 1998 to Euro 2007. Used in Land Rover Defender and Land Rover Discovery. Santana engines. In 1956, the Rover company held talks with Spanish engineering company Metalo de Santa Ana S.A. with the aim of starting Land Rover assembly in Spain. Under the terms of the agreement, Santana would initially build Land Rovers from complete knockdown kits shipped from Britain, but locally manufactured content would gradually be increased until the entire vehicles were built from scratch in Spain. Santana would also have exclusive sales rights in Spain, South America, Central America and North Africa, selling both Santana and Land Rover badged vehicles in these markets where necessary. Production at Santana started in 1958. From 1962 Santana began to improve and modify the Land Rover design to meet the demands of its own markets. These were the common demands of more power, better ride comfort and improved refinement. To this end, Santana produced several unique versions of the Land Rover engine designs it had rights to. These included 94 horsepower 3.3-litre six-cylinder versions of the 2.25-litre petrol and diesel engines in the late 1960s and a 75 horsepower turbocharged version of the 2.25 diesel in 1982. In the early 1980s, when Land Rover was looking for ways to improve its engine range, especially its diesels, the Santana engines were looked at. The six-cylinder version was considered too large and heavy for the Range Rover, but a turbocharged five-cylinder variant was considered since it provided an ideal blend of power, weight and size. The 2.25 TD was studied to provide development information for the diesel turbo engine. In the end, production reasons meant that Land Rover favored a diesel version of the Rover V8 instead. When that engine did not reach production, Range Rover diesel engines were brought in from VM Motory. References. Bibliography, Demock, E. 2006, The Land Rover File, Dove Publishing, ISBN 0-9534142-8-0, Gould, M. 2007, The Land Rover Scrapbook, Porter Press, ISBN 978-0-9056564-0-8, Hodder, M. 2000, You and Your, Land Rover 90, 110 and Defender, Haynes Publishing, ISBN 1-85960-667-9, Robson, G. 2003, Land Rover, Series 1 to Freelander, Crowwood Press, ISBN 1-86126-558-1, Taylor, J. 1988, The Land Rover, A Collector's Guide, 1948-1988, Motor Racing Publications, ISN M0-947981-25X, Taylor, J. 1995, Land Rover 90 and 110, 1983, 1990, Owners and Buyer's Guide, Yesteryear Books, ISBN 1-873078-17X, Taylor, J. 2007, Land Rover, 60 Years of the 4A, 4 Workhorse, Crowwood Press, ISBN 978-1-86126-965-2, reprints of contemporary road tests as published in Land Rover Series 3 1971 Euro 1985, published by Brooklands Books, official publications, Land Rover Series 3 Repair Operations Manual, 1981, Land Rover Limited. Land Rover 90 Defender Workshop Manual, republished edition by Brooklands Books 2008.